Okay, let's talk about vector addition. So the reason we talked about component form and regular form was to try and get an idea so that we could build this concept for vector addition. Vector addition is very useful in physics and a lot of other mathematics. The idea is basically if I have two vectors, what would it look like if I added them? So let's talk about it from a visual perspective. If I was to add two vectors, I'm going to put one where it would be. So this would be my starting point, and then I decide I'm going to change direction, and I use the other vector. Now, in theory, I would probably know how far and at what angle, and likewise, I would know how far this one is. Let's call it a D, and then we would know this angle here. Let's call it alpha. Okay. Now, there's two methods here. You can try and figure out some angles in that thing and do essentially triangle trigonometry, use law of cosines because you know these two sides. You can do some deductions, figure out some angles. Law of sines would help you there. And you can basically find how far and what angle. Or you can break this thing up into essentially components. So if I was to redraw this, it looks something like this. I know the standard position. We just talked about how to turn things into components. I can essentially just break it up into bits and figure out these triangles. So let's call this x1, y1, and y2, just this little chunk here, and x2. Now since these are right triangles, I would be given, again, the angles and the lengths of the hypotenuses. I would know these. So we can solve for our components and then essentially just add our components because we're just looking for this right here. And that would give us our components of our vector, which we could turn into standard form. It depends on which one you're more comfortable with. There's several ways you could do it. You can, depending on the situation, use which one you like. The idea is the same either way. Okay, so let's do one example just to put it into practice here. I'm going to take the vector 5, 6, and I'm going to add it to the vector -2, 4. So, in practice, what it's going to look like just as a picture here, 5, 6, meaning I go to the right 5 and up 6. And then I'm going to go left 2 and up 4. And ultimately, the only thing I'm looking for is start to finish, what's the angle, and how far. So, since I was given these things in component form, I'm going to make myself a little chart. I have x components and y components. My first x component is the 5. My second one is the -2. My first y component is the 6. And my second one is the 4. I'm just going to add these, and that'll give me my new components for essentially my red vector here. So 5 plus a -2 is going to be a +3. And then 6 plus 4 would be 10. Okay, so essentially, if I bring this red vector over here, I know I'm going to go some distance at some angle, but I do know that it's equivalent to going 3 units to the right and 10 units up. At this point, we can use right triangle trig and find L and theta. So let's find L first. For L, we can just use Pythagorean theorem. Since we know 2 of the sides, we're looking for the hypotenuse. So if I take 3 squared plus 10 squared, that has to equal L squared, which means that 109 has to equal L squared, which means that L has to equal square root of 109. Cool, that's L. All right, now let's find theta. Since we have a right triangle, we know for sure we have the opposite and adjacent sides, so we can use tangent. So tangent of theta has to equal opposite over adjacent, opposite in this case being the 10, adjacent being the 3. So this means that theta has to equal tangent inverse of 10/3. Which, if I run in my calculator, I roughly get that theta has to be about 73 degrees. Okay, so putting this all together, if I want to write it as a vector, I say we have to move square root of 109 units at 73 degrees. And that would be an example of how you can add vectors using the components. Now, you could have also applied law of cosines to this case, just drawing a few things, figuring out some angles here and there. But in this case, I feel like this would be the easier way to go. The components do buy you a lot. And if you aren't given the components, you can solve for them and just make our chart just like we did right here. Add them up, create a new right triangle, and then apply Pythagorean theorem and right triangle trig. It's a lot of steps, but each step is fairly simple as opposed to trying to do it all at once with law of cosines. Choice is yours. I hope this video was of use to you. Good luck.